Hi everyone, myself Manu KP, working as a lecturer in Government Polytechnic Kushalnagar in Electrical and Electronics Department. So in the 6th unit special motor, this is the session number 50th, we are discussing about the stepper motor. So in the previous session we just discussed about the reluctance motor and then the universal motor. In this session we will be discussing about regarding the stepper motor, its working, construction and applications, and some of the MCQ question we're going to discuss in stepper motor. In our day-to-day life, we are going to see most of these special motors in our day-to-day life, but we are not aware. So in these sessions now, we'll be making you to aware of what are the motors, special motors which we use in various applications in households and outside the households and industries and in different applications. We are now able to recognize these special motors. So now coming with this special motor, that's the stepper motor. So this is the picture of a stepper motor. Hmm. This is how it looked like, the stepper motor. It consists of the stator and the rotor. Here we call the stator as the phases and the rotor is the poles. We call the poles everywhere in the same way. These are just a diagram of the picture showing the stepper motor assemblies, stator as well as the rotors with all kind of connecting wires with the color wires black, red, yellow, green, and orange. These are the different phases. We can see here different phases of the stepper motors. So, what is a stepper motor? The first question which arises for us. A stepper motor or a step motor or stepping motor is a brushless DC electric motor that divides a full rotation into a number of equal steps. So, as the name itself indicates steps, so the motor will rotate in steps. Instead of giving the full round rotation of 360-degree, it will be giving the number of equal steps, this motor. And this is a brushless DC electric motor. It's a brushless DC electric motor. The stepper motor is so called as. So it doesn't require any brushes. So without brush, it's a DC electric motor, brushless electric motor, where the full rotation is divided into number of equal steps to complete one single rotation. The stepper motor can be considered as digital electromechanical device where each step command pulse, the electric pulse input results in the movement of the shaft by discrete angle called step angle of the motor. So this motor is also called digital electromechanical device. Why you call it digital? Means we are giving a signal, digital signals, 1, 2, 3, or 1, 0, 1, 0. These are digital signals. The signals will be carried through electro and the mechanical performance. The rotation takes place. Hence, the digital electromechanical device, where each step or the commands or electrical pulse input result in movement of the shaft by discrete angles or step angles of the motor. So for step angles, We are controlling the angles of rotation of the shaft by giving the electric pulse in the stepper motor. Hence, it's called as digital electromechanical device. It's a device. So, in stepper motor, when a given number of command pulses are supplied to the motor, the shaft will have turned through a known angle. When a command pulse is applied, the shaft will obviously rotate through a known angle. Through known angle, it has to rotate some angle from 2 degree to 90 degree or 180 degree max. We can able to rotate it. The motor can be used to control the position by keeping count of number of command pulses. The position you can able to control the position. It has to be rotated in angle, some angle. For example, the 45 degree, 90 degree. These are angles. It has to get positioned by itself. For that, we are have to give the number of command pulses to make it to that control position. Since command is in pulse, the motor is compatible to the digital system. All the commands which are we using now, they are in digital, in digital systems, the command systems. So next is the construction part. Obviously, when having the construction part, what is the stator and another one is the rotor. Now look at the diagram, the picture. The picture shows the stator. See, it consists of stator, the windings. 1, 2, 3, 4, 5, 6, 7, 8. 8 number of windings in there. We call it as phase in this diagram. Hmm? The phases. And the other one is rotor. It's the rotor. Here the stator is made up of silicon steel stamping with inward projected even or odd number of poles or teeth. So silicon steel stamping. The stator is made up of silicon steel stampings. Inward projected, even or odd number of poles or teeth. The teeth we are considering here, it may be even or odd, but it's been projected towards inward. Usually, the number of poles of stators is an even number. The poles has to be even, the north pole, south pole, so it becomes a couple, north and south, and it has to be even. The poles we have to take even numbers only. Each and every stator pole carries field coil or exciting coil. The poles now, since it's a stationary poles here, it carries the field coil or field winding or exciting winding. This in case of even number of poles, the exciting coils of the opposite poles are connected in series. Even though we are having even number of poles, here the opposite poles are connected in series. They've been connected in series. The two coils are connected in such that the MMF get added. The two coils which are opposite but connected in series, they're connected in such a way that the MMF which is going to get produced get added up. The combination of two coils is known as phase winding. These two combinations, this opposite polarity has been connected together, hence the two coils known as phase winding. Next is the rotor. See, rotor. We can see the diagram, no? The rotor, the picture, the actual, it's a stepper motor, how the rotor looks like. The rotor is also made up of silicon steel stampings with outward projected poles, and it does not have any electrical winding. Oh. It also has got the outward projected poles. What the rotor no? It's also projected outwards, but it does not contain any of the winding. The stator regards the winding, the opposite polarities being connected together here, but in rotor part, it does not have any electrical winding. The number of rotor poles should not be equal to number of stator poles to have self-starting capability and bidirectional rotation. So the number of rotor poles is not at all equal to number of stator poles. It must not be equal. Both has not be equal. If the rotor consists of the 4 poles, the stator must be consist of the 8 poles, 6 poles, 12 poles, like that. But it should not be always same. The width of the rotor teeth should be equal to the width of the stator teeth. The rotor teeth and stator teeth, they have to be equal. Then only we are able to do the working, produce the torque in angles, so that you can able to rotate the motor in step of angles. So next is the working. Working is very simple here. See, look at the diagram. What this diagram shows? This diagram shows it's an 4-phase, 2-pole stepper motor. Why the name is called as 4-pole, 2-pole, 4-phase? Since phases, no, we are giving supply to the pole with A, B, C, D in different names through an DC supply here, through a semiconductor switch. Semiconductor switch. Here, since it's a 4-phase, 2-pole stepper motor, 4-phase, 2-pole stepper motor, we have to give the switch name as SA, SP, SC, and ST based on the connection which we have given for the supply. So the phase winding of the stator are energized in sequence A, B, C, D. So by this applying the switches now we can able to energize the phase. Coming with the topmost, it's a A, and the right B, and the bottom C, and the left D. These are the phases, 4 phases and the 2 poles. The rotor aligns itself with the axis of the phase A as the winding A is energized. The rotor is stable in this position and cannot move until the phase A is de-energized. The phase B is energized and the phase A is disconnected. The rotor moves 90 degrees in the clockwise direction to align with the resultant air gap field which lies along the axis of the B. So what does it indicate means we are using semiconductor switch here. When we close semiconductor switch SA, then the current will start flowing through the phase A. Then this rotor, this rotor gets shifted to the phase A and still remains there until and then the coil A is get de-energized. If we want the phase B to excite, then we have to disconnect phase A, switch A, and we have to connect B. Then it moves in the clockwise direction. What the rotor, no, the rotor will move in clockwise direction in order to achieve the stator. It has to get aligned with the phase B, axis of the phase B. Similarly, the phase C. So, if you want to further rotate the poles to another 90 degree, then we have to energize the phase C. How are you going to energize phase C? By closing the switch SC and opening SA and SP. This been disconnected. So when this is disconnected, then the rotor, the rotor will align in the phase C. If you further want D to get energized, then we need to turn off the SC switch C. Then we need to close SD. Then the rotor will be shifting again 90 degree. The phases are excited in order of A, B, C, D, A. The rotor moves in 90 degree at each transition step in the clockwise direction. The rotor completes one revolution in 4 steps. So by applying this switches, by calling the switches, we are giving the command pulse for the machine to rotate how much angle, whether it is 90 degree, 45 degree, or 180 degree in the clockwise direction. So the direction of rotation depends on the sequence of switching the phase. So the direction and that does not depend on the direction of the current flowing through the phase. Thus the direction can be reversed by changing the phase sequence A, D, C, B, A. What does this mean? The direction. Since it's all command, we have the command giving the command pulse, no? The direction also can be changed, the sequence of direction. Since we first close the switch S A, the phase A get energized. So the rotor will get shifted towards the phase A and stands there until and then the A switch semiconductor switch is present on. Now if we instead of going behind for P, if we make it D to turn on, this will turn on, then the switch SA is to be removed, open, then SD has to be logged in. Then the rotor, which was exactly in the upward direction, will shift or rotate towards the left direction, because the switch SD is being operated. So again, if we go for an anti-clockwise, then the C is energized, then the B is energized, ultimately A. So the magnitude of the step angle of the variable reluctance motor is given by alpha is equal to 360 divided by S, MS and NR, where alpha is the step angle, the angle at which it is going to rotate. MS is the number of stator phases. NR is the number of rotor teeth, the number of rotor teeth we are using now, that one. MS is the number of stator phase. So the step angle is expressed as the alpha is expressed as ns minus nr by ns into nr whole into 360 degree, where alpha is stepper angle, m is the number of stator phase, nr is the number of rotor phase, ns is the number of stator poles. So this is the equation to get the step angle. So next is the application. Here the application, wide variety of the application we are using this stepper motor. One is the printer to drag the papers initially, tape driver. The tape driver means in the olden days we used to use the tape recorder, no? For that is tape drivers. Next the disk drives. Where it drives, no disk drives, it has to move some angle. For that purpose also we are going for stepper motor. Processing control system, machine tools, X-ray recorder, robotics, textile industries, and 3D printing. These are the various application of stepper motor, and also the stepper motor will be in present in nowadays car, as we call it one as a power windows. If we close one window, then every window will be closing. Some angles. For that purposes, we are using a stepper motor. Next is the MCQ question. Okay, we start from here. A variable reluctance stepper motor is constructed of dash material with salient pole. Paramagnet, ferromagnet, diamagnet, or non-magnetic. So the answer is ferromagnet is the right answer. The variable reluctance stepper motor is constructed. A step angle can be adjusted by changing the number of poles of the rotor, changing the number of phase of the rotor, altering sequence of excitation, all of the above. So this for step angle, all these three factors come into picture. One is changing the number of poles on the rotor. By changing number of poles on the rotor, step angle can be varied. Also by number of phase on the stator. So we can decrease or increase the phases. In the same way, we can decrease or increase the poles. The last one is altering the sequence of excitation. The answer is all of the above. So the sequence of excitation also can be used for stepper angle. The number of phases of the stator also we can able to achieve. Number of poles of the rotor can also be changed. Every bit of thing can be changed here. The third question. The rotor of stepper motor has no winding, commutator, brush, all of the above. So the rotor of the rotating part of the motor or stepper motor has no winding. Since it doesn't contain any winding, then there will be no commutator as well as brush. So rotor of stepper motor is an has number of winding, commutator, brush, has no winding, no commutator, no brushes, nothing will be there. All of the above. Next, the stepping motor is dash device. Is a mechanical device, electrical device, only device, or incremental device. As the name itself indicates, it's increment. Increment is what? In steps. Step 1, step 2, step 3. So it's an incremental. The stepper motor is a motor in which the motion in the form of steps and is incremental device by which has time increases, the steps are increased. As we go on, keep on giving the command pulses, no, then it will keep on increasing. The signals pulse increasing, it will keep on moving in the same direction. This is that. Next one, the rotational speed of a given stepper motor is determined by solely by shaft load, step pulse frequency, polarity of the stator current, magnitude of the stator current. The answer is B. Step pulse frequency. So rotational speed is determined by step pulse frequency. The stator part of the motor is the stationary part. Yeah, stator is the stationary part. And rotational speed is given stepper motor is given by step pulse frequency. The rotational pulse is by step pulse frequency. How the pulse frequency is being given. A stepper motor may be considered as dash converter, digital to analog. We are giving steps in terms of digits, it will be converting into analog and executing. In CNC machine for positioning of the blades, dash motor is used. Is stepper motor. For CNC machine, no, for positioning, where it has to position for cutting or drawing, no. So hence, this stepper motor is being used in order to control the directions. In permanent manual stepper motor, the direction of the motor is dash to the direction of the current flow in wind. Dependent, reverse, independent, and none of the above. Is dependent means the direction of the motor is depend to the direction of the current in the winding. Obviously, it has to be depend. When the motor speed of the stepper motor increases, the torque will dash decreases. So obviously they are in relation opposite, hmm? Inversely proportional speed and the motor. Hence the torque will be decreased as the speed keeps on increasing. Obviously the torque will be reduced. Last one of the session. The stepper motor has full torque at dash 0, normal 0, all of the above. So the stepper motor has full torque at 0 speed. When the torque is high maximum, when the speed is 0. So this was a brief introduction about the stepper motor, how it going to work. The stepper motor is nothing but consists of the 4 phases and 2 poles. When pole A is being excited, this is the question, is being excited, and the stator, it will keep on moving. So it's a brushless DC motor. So these are the reference books, BL Tereja and VK Mehta reviews. These are the internet questions which I just introduced. So these are our team members with whom we are able to perform this LMS function. Thank you. This is the end of session. Thank you.